You accidentally press this one? Okay. That's kind of cool.
Okay, so here's what we're doing. We've got polynomial functions, and today's just going to be a quick intro on stuff that, again, a lot of this stuff y'all have seen it before. You know it. We just got to make sure that y'all understand what it is before we move into the other things we got to do, because there's a bunch of other things that we got to do that if you don't remember these basics, it's going to be hard to know what to do. So we got to kind of step back for just a minute and kind of pick up on everything. All right, so very first thing is when we're talking about polynomial functions. If we're doing chapters, this is chapter 3.1. Not that that's really important to y'all. But first thing we got to talk about is when you talk about polynomial functions, you're going to talk about terms inside the polynomial function. And for terms, the terms are separated by a plus or a minus. Not positives and negatives in this case, but this is where you got 2x plus 3 and 5x minus 6 and those kind of things. And we've already, we talked about quadratics where we were graphing and factoring and doing all this stuff. That most everything was either 2 or 3 or 4 terms. If when we had our factoring sheet, we were going. And when you're setting this thing up, the way they talk about terms for this thing is that each term has a different variable power. Or there could be multiple variables, so we'll say variable or variables. Each term has a different variable power when it comes off of it. All right, we're going to go way back here. And when we're doing these polynomial functions, they're going to ask you to name it by a couple of different ways. Probably one of the first things they're going to ask you to do is to name it by the number of terms. All right, if you have one term, that's a monomial. Now, if everybody goes, oh yeah, I remember those. If it's a monomial with one term, if you need an example of that could be like 4x squared. If you got two terms, of course that's a binomial. That could be 3x minus 6, where there's your first term, there's your minus, and there's your second term. And then three terms, which so hopefully nobody's surprised, is a trinomial. And we've been doing a lot with the trinomials because that was the factoring, that was the graphing, that was a lot of those. Now, they were quadratics in most cases, but that's a lot of the stuff that we were doing where it was, x squared minus, 5x plus 10 or something like that. Okay, now everything after three terms does not have a specific name. Whether it's 4 terms or 5 terms or 6 terms, they just kind of got lazy and they're like, we don't give everything else a name. So we're just basically going to see this, is that anything after that, if it's a n terms, where n is greater than 4, or we'll just say it's greater than 3. Again, it doesn't have a specific name. It's just they just call it a n-term polynomial. So if you've got a polynomial that's got 6 terms, they just call it a 6-term polynomial. If it's got 4 terms, seems like 4 they'd actually have a specific name for it, but they don't. But if it's 4 terms, it's just called a 4-term polynomial. So it doesn't have a specific name for it. It's just basically just tell me how many terms it has, and that's basically what the name of it's going to be. Okay, so really just 1, 2, 3, and then everything else after that is going to be a 4-term polynomial, 5-term polynomial, 6-term polynomial, whatever the thing is going to be. All right, and then the second thing is they're going to talk about degree. And the degree is the highest power of a specified variable. "99 times out of 100, that specific variable is going to be X, but occasionally they might ask you to find Y or some other one. But just think that, it's, again, 99 times out of 100 is going to be X for this thing. All right, so we're going to do a little chart here. So we're going to name it by degree. We're going to tell what the degree is, of course. And then we're going to give you an example of it over here. Okay, so if you name it by degree, if it's degree 0, which basically means it doesn't have, so if you think about it, it's x to the 0 power is basically what it's saying. That means it actually doesn't have x in there, that's going to be a constant. And they talk about and we're just going to do these as equations, where we're going to have y equals for all this stuff over here. An example of a constant, well, that's 4. Doesn't matter what you plug in for x, there's no x there, so the answer is always 4. So if it's just a number, then that's what it's going to be. It could be 4, could be 8, could be -6, could be 5. Could be any of those things. But it's just a number for this thing. All right, if your degree is 1, all right, if it was something like this, the example of it would be y equals 2x minus 5. If you graph this thing, what does that graph look like? What shape is the graph going to be? It's going to be a line, right? So they call this thing linear, because if no matter how you do this, if you do x to the first power, it's always going to make a line. So this one, there is no x, so that's why it's 0 power. This one's x to the first power, so it's degree 1. If we go degree 2, go back to the last 2 tests of things we've been working on. If it was x squared minus 13x plus 7, if you graphed x squared, what kind of graph do we say that was? Yeah, that's parabola, right? But we said in that case, what was the equation we used there at the very end to find any answer we want to do? You can plug it into the blank formula, quadratic formula. So this thing's called a quadratic, which is a little bit confusing because if you think quad, normally you think 4, right? But for some reason, quadratic in this case is 2. I don't know. This is the way the rules are, and we kind of go with it. So, all right. If we go to the third power, degree 3, that could be -4x to the third plus 10 or something like that. All right. If we go degree 3, that's cubed, so they call it a cubic. Name it by degree. Okay, and we're only going to go to 5 for the degree on these. So we're doing x to the 4th. Example of what it looks like, maybe something like that. Okay, and this is where 4 comes in, because if we talk about 4s of anything, like it takes 4 quarts to make a gallon, right? 4 quarters to make $1. So for this one, they kind of go with the quart part of it, so it's quartic. All right, and then the last name they actually have you look at is degree 5. That one is quintic because if you have I heard it this morning on the way in, there was somebody had a uh, maybe the first one that's happened that they know of, but it was 5 identical daughters being born. Had 5 identical quintuplets being born yesterday.
Be like the once you get blue hair, if they're sad.
Okay, and just an example: negative 7x to the 5th minus 2x plus 3. Okay, but again, when you're talking about degree, you're talking about the highest powered term that's there. So it's x to the 5th, x to the 4th, x to the 3rd. Technically, again, that would technically be x to the first power. There is no x here, so if there is no x, that's why it's degree 0. All right, and then the last little thing that y'all have heard on this before, standard form. And y'all have been doing this for a long time, so this shouldn't be really any big deal to it. Standard form is where you write the terms in descending order. Based? How about based? Based on the degree or based on the powers of the variable terms. Okay, so standard form, you write the terms in descending order based on the powers of the variable, not the numbers themselves, but it's always on the variable power. And one little thing on that one is that when you rewrite it in standard form, the first term, that's equal to what they're going to call the leading term or the leading coefficient. First term, let's say has. I should have put first term has the leading coefficient. It's not the leading coefficient, but that's the one that kind of sets the train for everything else. Just like when we were graphing, you remember when we were graphing the quadratics, if the first x squared term was positive when you went up, if it was negative when you went down. So that's when they talk about the leading coefficient, you're always going back to the first term, and you're going to tell me, all right, is that first term positive or negative? Because that's going to tell you the basic shapes of any graph that you're going to do when it comes off that thing. Okay, so what we're going to do is there are going to be some problems in the homework, and it's going to ask you to, we're going to do all 3 of these things together here at one time. So you're going to write the expression in standard form. And you're going to classify it by degree and the number of terms. Okay, so we got 3x to the 3rd minus x plus 5x to the 4th. Okay, so very first thing I would do on these is the one thing you want to remember is that the plus or minus sign that's in front of the terms goes with it. So if you're trying to figure out how many terms it has, that plus will go with the 5x to the 4th. That minus will go with the x. And technically there's a plus that would be there with that 3x to the third, and that one would go with that part. And that's going to separate out your terms, and then from there you go with the highest power. We've got 5x to the fourth. Next highest power is x to the third, so it's going to be plus 3x to the third and minus x. Okay, so there's your standard form. Basically, when you circle this thing, you know that you now got three terms. So if it's got three terms, that's a trinomial. We've got our standard form, and for the degree in this case, your highest power of x is x to the fourth. So the degree is equal to 4. And if degree is 4, they'll either let you do degree 4, or they may tell you then that it's quartic. Okay, so it's got three terms, which is trinomial. The degree is 4, which is quartic, and there's your standard form because we started with the highest power of x and worked our way down. All right, should be pretty easy enough, right? Just take the terms, rewrite it, kind of go from there. Nothing, shouldn't be anything really too different on this thing to throw you off. All right, so for number 2, we'll go 3 minus 4x squared plus 5x minus 10x to the third. Okay. Again, to me, the easiest thing to do is go back and just circle, because a lot of times people move these around, they'll forget the signs with it. So I'd go back and like actually circle, from the back forward, so that you know that every sign goes with the number that's in front of there. So that sign goes with this number, that there, that one there, and again that leaves that 3 by itself, but technically that would be a positive 3. All right, so we've got the negative 10x to the third is first, minus 4x squared plus 5x plus 3. And there's our standard form. All right, we've got 1, 2, 3, 4 terms because we've got it written. So that's a 4-term. And probably in that case, they may not, if it's 4-term polynomial, they may just ask you to name the number of terms, so it's just got 4 terms. Because technically it would be a 4-term polynomial. That's all you can do to name it. All right, we started with x to the third. So the degree is 3, which is cubic. Okay, and here's now the only trick to this one, and there's only really one trick they can do to this thing. And it's not even that big a trick once you kind of see it. You go, oh, well, that makes sense. If you start going ahead and moving everything around, figuring out what you have here, we've got the positive 12. We've got a positive 5x squared. We've got a minus 10 and then a minus 16x. Okay, so we start with our highest power of x. That's 5x squared. We don't need the plus in front of the 5. We've got a minus 16x. And we've got a negative 10 plus 12. All right. And if you say that there's 4 terms here, you're absolutely 100% wrong. Because what can you do with negative 10 plus 12? Yeah, just put together, right? You can simplify that part. So if you have parts in here that you can simplify by combining like terms, they tell you you've got to combine all your like terms together. And then once you got your like terms together, then you can go back and, figure out what you got. So for this thing, it's technically 5x squared minus 16x plus 2. So technically it has 3 terms, which again, it's trinomial. And your highest power is x squared, so it's degree 2, which would be a quadratic. And I think the way it's set up in Math Excel is that they will have a drop down menu for degree. They'll have a drop down menu, and they'll either give you the numbers or they give you the name. And same thing on these, they'll either give you a drop down menu of like monomial, binomial, trinomial, or some other weird name they may throw at you there. But it's again, it's all pretty straightforward. It's just y'all have done standard form for probably 4 years, so that's not anything big. It's just make sure we go back and realize when they start throwing out different names, just realize what some of those names are and some of the stuff we're going to do. All right, and then the last thing we're going to do today. Again, we'll get to building this a little bit more tomorrow, and then a little bit more, next week when we go through this thing. The last thing that we're going to do, and this is where we kind of use this to move into some other things that we're going to do. Is we're going to talk about the end behavior of graphs. Now, not in the middle, because we'll worry about the middle a little bit later on, but right now we're going to do just the end behavior. And when we talk about the end behavior of graphs, this thing is basically here. It's based on the leading term. So after you've got it rearranged, you've got it written in standard form where you've got your highest power of x first and you get your degree from there, then everything we're going to do is based on just your leading term. All right, if you want to make a kind of a tic-tac-toe box here. Okay, again, when we're talking about the leading term, we're talking about the first term when it's written in standard form, because that's the big thing we're going to do. Okay, so we got our leading term here, and this is going to determine everything else we're going to do. And when we're talking about the leading term, it can only be one of two things. It can either be positive or it can be negative. And somebody may be saying, what about if it's 0? Well, what happens if you do 0 times anything at your first term? It becomes 0, right? And then now by default, because that's 0, it's going to move to the end, and something else would wind up being your leading term. So for this part of it, your first term will never be 0, because that should basically go to the end and be a constant. It's either going to be positive or it's going to be negative, just because of how things can be set up. All right, and based on what we're going to do for this one, your degree is either going to be even or your degree is going to be odd. So we're basically right now we're going to take the constant term, we're going to throw it out. So, all right, it's not a constant because a constant technically, if we get down to it, it's not technically, I guess, a polynomial function when it comes off of it. So we're going to look at everything like x squared, x to the third, x to the fourth, x to the fifth, x to the sixth, all those things like that when it comes off of it. So if your leading term is x to the second, x to the fourth, x to the sixth, x to the eighth, kind of like that, this is what we're looking at. If it's odd, and we kind of skip over x to the first because x to the first is linear. There's no curves to it, so it's kind of cheating a little bit. So it's x to the fifth, x to the third, x to the seventh, those kind of things. All right, now let's flash back to the last test because we've graphed x squared. What did we know the graph looked like if it was x squared and the first term was positive? Which way did the graph go? Yeah, everything pointed up, right? So if we talk about the ends on this one, if we talk, and again, we're not talking about what's happening in the middle. We're going to talk about the left side of the graph and the right side of the graph. The left side of the graph pointed up, and the right side of the graph also pointed up. So they ask you about end behavior. You're just going to say up and up. Okay, so what do we know if it was a negative number? It was x squared. Everything was down, right? So the left side was down, and the right side was also down. So this one, you just have to think for this one, just think back to x squared. That what happens if we were graphing x squared and the first number was positive? Well, we knew the graph was going to look something like this, right? Again, we're not worried about what's happening in the middle. We're worried about what's happening on the ends of it. If it was negative, we knew it was going to look something like that. All right, so if it was negative, or if the degree was even, we had those two things. If it was an odd degree, x to the third, x to the fifth, x to the seventh is your leading term. This one, you just want to think slope. Because what happens if you have a positive sloped line? What does it look like? Right side's up, left side's down, right? So for that one, you're going to say that. You're going to say, all right, the left side is going to be down, and the right side is going to be up. Okay, and if you think about something that's a negative slope, it's the opposite. It looks like this. So we've got that the left side is going to be up, and the right side is going to be down. Okay, so when they describe end behavior, all you're going to do is you're going to tell me some combination of up and down. Left is first, right is second, because that's kind of the way we're going to go with it. And let me just kind of show you one real quick, and then we'll come back in and talk about this a little bit more tomorrow. So let's say they gave you y equals negative 12x to the third plus 16x plus 25x to the fifth plus 4. And they would say, all right, here's this equation of an expression. Tell me what's the end behavior of this thing. All right, and all you have to do is, on these, you have to find out what's my biggest power of x, which is x to the fifth. So that's our leading term. And you're going to tell me two things. First off, is it positive or negative? It's positive, okay? So that puts us up here on this positive part of it. And then it's positive, and it's x to what kind of power, even or odd? It's odd, right? So then all you're going to do is you're going to take the little chart we've got here. You're going to go to the positive. You're going to go to x to the odd. And it means it's going to be down and up. So your answer is going to be down and up. Because the left side's going to be down and the right side's going to be up. And for now, that's all we're going to do. And you may be thinking, well, where does that go? When we tie in the middle of the graph later on, this will start to make more sense when we kind of start tying this stuff together.